Alright, welcome back, guys. So, I'm going to go over the review for the final exam. So, your final exam is going to look just like this review, except it's not going to have quite as many questions. You'll notice there's a lot of questions on the review. The final doesn't have quite as many. And also, guys, in this review, some questions are kind of repeated, so I may skip one or two here and there. But these go in order in which we cover the material in class. Okay, so we'll get started. Let me zoom in just a bit. Okay. So, and I was marking the ones that I want to do, which is basically most of them. All right, number 1, it says identify the logical fallacy demonstrated by the following. It says each of my friends' 3 cats catch mice. Therefore, so this is your if you remember, this is your conclusion over here, and this is your premise, okay? Each of my 3 cats catch mice, and then the conclusion, therefore all cats catch mice. So this is an example of a hasty generalization. Okay? Just because those 3 cats catch mice doesn't mean all cats catch mice. We're going to skip number 2. It's just like the number 1. Number 3. A television commercial shows 2 people who fall in love while drinking a certain brand of soft drink. So we are bombarded with commercials like this, aren't we? And this is an appeal to emotion, guys. And it can be an appeal to a positive or a negative emotion, right? An appeal to fear, for example. Alright, so now we're going to get into some of the material from Chapter 2. We were doing those unit conversions. So this says convert 6 feet to inches. So if you remember, you're going to start out with 6 feet, and put that over 1, and you multiply it by 1 or more conversion factors. Well, we know that there's 12 inches in a foot, and I want my feet to cancel. So my conversion factor, I'm going to put 1 foot in the denominator and 12 inches in the numerator. Okay. And then just like we've seen, those units feet are going to divide out. We'll just multiply straight across. 6 times 12 is 72, and the unit left is going to be inches. Okay. So 72 inches. We're going to skip number 5 because it's just like number 6. Number 6, convert 9 years to hours, neglecting leap years. Okay, so we're going to assume every year has 365 days in it. So let's start out with 9 years. Put that over 1 times. Now we need to go from years, which is a larger unit of time. Oops, my computer froze. To a smaller unit of time. So I'm going to try to go from years to days. So I know that in 1 year, I need my year to go in the denominator. There are 365 days. And guys, while you're doing this, you can go ahead and cancel those out. Okay, so now we're left with days. But we're trying to go to hours. And so now we need to convert days into hours. So now you can say you want your days to cancel, and in 1 day there are 24 hours. Okay? So your days cancel, and now we've got the unit hours, which is what we want. We've got a series of 1s in the denominators, so that's not going to make any difference. But let's multiply what we have in the numerators. 9 times 365 times 24. So 78,840 hours, okay, in 9 years. All right, number 7. It says carry out the indicated unit conversion. Round your answer if appropriate. So it says there's 8 ounces in a cup. You culinary students will be familiar with this. 4 cups in a quart and 4 quarts in a gallon. So it says using a chain with these conversions converts 6 gallons into ounces. So we're going to start with 6 gallons. Now we're going to go from gallons to quarts. And it says right here, these are all your conversion factors. In 1 gallon, there are 4 quarts. Okay? So your gallons will cancel out. And now we need to go from quarts to cups. So here's your next conversion factor. This says that in 1 quart, there are 4 cups. So our quarts would cancel out. Now we'll use this last one. In 1 cup, there are 8 ounces. Okay? And I'll go ahead and explicitly show that these units are dividing out, and we're just going to be left with ounces. Again, we've got a series of 1s in the denominator, so we're not going to worry about that. We're just going to multiply 6 times 4 times 4 times 8, or 24 times 32. And we're going to get 768 ounces. Okay. All right. Number 8. This says, recently, $1 was worth about 12.73 Mexican pesos. So how much would $535 be worth in Mexican pesos? So guys, we start out with the $535. Okay? And this is our conversion factor right here. $1 is equal to 12.73 pesos. Okay? So your US dollars are going to cancel and divide out. And we're going to be left with pesos. Looking at this multiple choice, it looks like it's going to be C, but 535 times 12.73, and this gives us 6,810.55 pesos. Oops. Okay, so this is in fact going to be C. All right, number 9. So number 9 would be from our foray into chapter 3. So it says write the number in ordinary notation. So I have the number here expressed in scientific notation. And it's 4.67 times 10 to the 4th. So guys, remember, think about it like this. 10 to the 4th is a big number. So to make this number big, we need to move the decimal to the right. That'll make it bigger. I'm going to move it to the right 4 places. Okay, 1, 2, 3, 4. And if we fill in those empty places with zeros, we're going to have 46,700. All right, number 10. Now here we're going in the opposite direction. It says write the number in scientific notation. So we're starting out with the number written in standard ordinary notation. And so the decimal is understood to be at the very end. So if I put it behind the 6, I'm going to have moved it 6 times. Okay. So this will become 6.2 times 10 to the, and then this is the question here. I moved it 6 times. What exponent do I use? Well, think about it this way. We started out with a big number. We made it really small. So to offset that, I need to make my power of 10 big. So I need my power of 10 to be a positive 6. Okay. This is choice D. Alright, and with this, guys, now we are venturing into Chapter 4 material. Okay. You'll notice, having seen questions like these throughout the course, it says determine whether the spending pattern described is at, above, or below the national average. Assume that any salaries or wages are after tax. Okay. So it says a couple in their 40s with a combined household income of $38,000. Ooh, that's not too good. Per year spends $410 per month on transportation. Okay. Yeah, that's not a whole lot of money for two people. All right, so what we need to do, because if you look at this chart here, guys, this gives spending as a percentage. Okay, and we've got these different age groups. So if they're in their 40s, they're going to be in the dark color here. So we're talking about transportation. So if I look at transportation, the dark bar comes out, it's real close to 20, okay? Maybe a little bit shy of 20%. All right, so we need to see what percentage they're spending on transportation per year, okay? Well, remember, they're earning $38,000 per year, and they're spending $410 per month on transportation. So we first need to convert those months into a year. So $410 times 12 months in a year. And this is, let's see. Okay. $4,920. Now we're going to divide this by their total salary. It's $38,000. Okay. They must work in education. All right, now when I do this division, I'm going to get a decimal. And then we'll convert that decimal to a percentage. Okay, so this is my decimal. If I multiply it by 100, that'll convert it into a percentage. And guys, they're spending a little bit shy of 13% on transportation. So the average is actually close to 20%, so they're spending below average on transportation. Okay. Alright, we'll keep going. I think, let's see, I had kind of marked off the questions through Chapter 4, so that may be a good stopping point. Because Chapter 4 was on finances for the Part 1 video anyway. Alright, number 12, it says, find the monthly interest payments in the situation described. Assume that monthly interest rates are 1/12 of the annual interest rate. And it says Joseph maintains an average balance of $900 on his credit card, which carries an annual interest rate of 24%. Okay. First thing we need to do is figure out what that monthly interest rate is. So if the annual interest rate is 24%, just divide it by 12. And you get 2%, okay, monthly. Now we need to figure out, well, what is 2% of his balance? 900. Okay. So this is where you convert 2% to a decimal. So it becomes 0.02 times 900. And this is what he's going to spend on interest. $18 for that first month. Okay. So the $18. All right. Number 13. Says use the compound interest formula for compounding more than once a year to determine the accumulated balance after the stated period of time. Okay. So here we have $5,000 it's being deposited at an APR of 4% with monthly compounding. All right, so let me remind you of the formula. The accumulated value of an investment is equal to the principal times 1 plus the APR as a decimal divided by the number of compounding periods per year, and you raise this to the number of years times the number of compounding periods. Okay. So if it's monthly compounding, then that means that n has a value of 12. And so when you plug in these parameters, the principal, or that's being invested, is $5,000 times 1 plus, if the APR is 4% as a decimal, that'll be 0.04 divided by 12, and raise this whole thing to it says 2 years, so 2 times 12. Okay. And guys, remember, this is one that you can type it in exactly the way you have it written. There's those parentheses. Let's raise this to the power of, we could just say 24, right? 2 times 12 is 24. And we hit enter. We end up with a final balance after 2 years of $5,415, and you're going to want to round to the nearest cent. And there's a 4 behind the 1, so this is going to stay 71 cents. Okay, so a little over $400 earned there in 2 years. But 4%, it's not horrible. That's not great either. In fact, at the time of this recording, you can, for cash that you can that's liquid, that you can just have access to almost immediately. You can put your money in money market accounts. Many of them are paying around 4% interest at the moment. Number 4 says, suppose that you want to have $188,346 retirement fund after 41 years. How much will you need to deposit now if you can obtain an APR of 6% compounded daily? Assume that no additional deposits are being made to the account. So this is the problem in which you're trying to figure out, how much do I invest today such that I have X amount of money in the future? Okay. And let me write this formula down. So you're looking for just the opposite. You're looking for the principal, or in other words, how much you need to invest today. And the formula is equal to the future value, okay, which would be the $188,000, divided by 1 plus, the rest of this is pretty similar. The APR divided by n, and then you raise that to the y times n power, number of years. And make sure all of this down here stays in your denominator. All right, so I'm going to plug this number, plug in the parameters. We want to have $188,000, $188,346 in 41 years, basically. Okay, so 1 plus, it says 6%, so 6% is a decimal. Compounded daily, well, daily means there'd be a total of 365 compounding periods. All right, over 41 years times the number of compounding periods. Okay, 6%. That's not a bad rate. With investing, there's some things that have hardly any risk, and you can lock in a rate of like 4 or 5, maybe 6%. That means you're guaranteed to get that. Okay. as the opportunity for greater return increases, so too does the risk. Okay, so there could be other things where you could potentially get 12 or 15% APR, but the risk of losing everything is much higher as well. So it's exactly like gambling. I'm going to plug this into the calculator. And make sure you keep all of this in parentheses that you have in the denominator. Or, well, at least the part that's in parentheses right here. Yeah. I've got 365 days. Okay, those parentheses raise this to a power of 41 times 365. Now remember, on this one, we're looking for a value that's smaller. Okay. Well, this one is definitely smaller, and it's surprisingly smaller. You might even think, man, I wonder if I did this wrong. $16,094.58, okay. Which would be choice A. And the thing is, guys, like I said, 6% is not a bad rate. That's actually fairly decent. And for 41 years, that's that power of compounding. But if you could deposit this right now, in 41 years, or whenever you retire, you'd have this much. Now, this isn't really all that realistic, because if all you have it when you get ready to retire is this much, you're not going to be able to make it. Really, these days, guys, you need like at least $1 million to be able to have a decent, if that's your only source of retirement. Social Security, I'm not so sure about. I've been making my financial decisions such that I am planning not to be able to get Social Security. I don't feel like it's something that I can really count on. So I'm trying to plan accordingly. If I am able to get it, then that'll be great. But as of now, I know I'm only going to get a certain percentage of what I would typically have gotten. Anyway. Alright, I think I'll do a couple more and then stop this first part 1 video. Calculate the amount of interest you'll have at the end of the indicated period. You invest $49,100 into an account that pays simple interest of 2% for 3 years. Well, for this one, guys, we need that simple interest formula, which is this. The accumulated value is equal to the principal times 1 plus APR times the number of years. Okay. Remember, the difference with this one is that the y is not the exponent anymore. This is why we get the linear growth as opposed to exponential growth. Okay. All right, so the principal, or what we're investing, is $49,100 times 1 plus, it's 2%, okay, it's a decimal. And then times the number of years, it's for 3 years. And we can plug this into the calculator real quick. 49,100 in parentheses 1 plus 0.02 times 3. And this is our total. $52,046. Okay. Now it's not asking for the total; it's asking what's the amount of interest that we will have paid at the end of this period. So what you would have to do now is subtract from that final amount whatever the initial amount was. Okay. and this will give you the amount of interest. So if I take that and subtract from it what we invested, this will tell us how much interest we've earned. $2,946. Okay, this can be choice A. Alright, last one right here. It says find the annual percentage yield. Now this is one we didn't go into great depth with. But remember, the annual percentage yield is the actual percentage by which your money increases. It's not the same as the APR. Now they're very close. The only time they would be exactly the same is if the interest is compounded exactly once a year. And the APR would equal the APY. Okay. To find APY, we're going to need another formula. It's going to be 1 plus APR over n raised to the power of y times n, and then minus 1. Okay? So a lot of this is still the same. This will actually calculate how much a dollar will grow to, okay, over a year. And then if you subtract that dollar, that'll tell you the actual increase, okay, of that dollar. And then, well, you have to convert it to a percent at the very end. But anyway, let's plug in these parameters, okay. So we've got 1 plus, the APR is 0.069, and we have compounding, daily compounding again, okay. Actually, I'll put something that we didn't need up here. We don't need the y, because we're treating this over a 1 year period. We just need the n up there. And then we'll subtract 1 from this. So 1 plus 0.069 divided by 365. I'm going to raise this to the power of 365. So what we get right here is basically what our dollar has grown to. $1 invested would have grown to $1.07. Okay. So to actually see by how much the dollar increased, we're going to subtract the dollar. So now we're going to say minus 1. And this is it. It's increased by 7 cents. Okay. Well, but we need this as a percentage. So the last thing you're going to do is multiply by 100. And that'll tell you the actual percentage of the percentage yield. So this is rounded 2 decimal places, so this would be 7.14. I'll put this is equal to 0.0714. And then as a percentage, it would be 7.14%. Okay. And this one isn't multiple choice, so make sure you do your rounding correctly. All right, guys. Well, we've gone close to 30 minutes. And we've gotten through all the material through chapter 4. Okay, so we'll start off working on material from chapter 5 in the next video.